Good evening. Today I'm going to be giving a really crash course into the beginnings of coding or programming. So I often get asked, like, where do I start? And then I often ask, well, what do you want to do? So here's so we'll go through a few examples of where you can go with it. It's not an exhaustive list, but it's just some ideas, and then we'll go straight into just programming something, and then it's a bit of a springboard. And then hopefully, if there's any feedback or anything like that, give me an idea of where to go next. So, without further ado, we're going to be covering basic fundamentals of programming. A lot of people, like myself, got into programming for businesses, for work. So this is stuff like, there's lots of disciplines of data analysis. I do e-commerce, about a decade of it. Could be management systems. It's not very exciting, but it's where the steady money is, and also hazard that it's easier, it's less competitive, because not everybody really wants to do it. That could be a really controversial thing to say, and I might regret it, but it's out there now. But it's always been my dream to be a business programmer, and I love e-commerce site programming. I like the house it bought. You might just be here as a hobbyist, like you just want to know how things work. Just got a bit of curiosity, which is fabulous. I think that's the ideal place to be. You might be wanting to get into game development. When I was much younger, I got involved because I wanted to modify games I played. I wanted to eventually make my own games, because they were colourful and there's movements, there's graphics. Obviously the fundamentals are the same, but the act of programming, say a racing game with 3D graphics, is a lot different to programming a plugin for WordPress to sell t-shirts. They're entirely different, but they're based on the same principles. And also, another use is hacking and security, as in you might be wanting to write tools or scripts to overcome security systems, or you might be on the other side where you want to defend against such attacks, or both. You might want to know how to undermine security systems, so you know how to counter it, or have an idea the process of building one of those tools. And it all comes down, I think, to programming coding anyway, but these are like the vast different areas you can go into. So without further ado, I'm going to start with an interpreted language. Don't worry what that means, called Python, because it's accessible. There's lots of documentations, and all four of these areas you could technically use it for. So I'm not pigeonholing you yet, but the fundamentals we will learn, we can apply to many different languages, and you can follow along in any language you like. I'm just going to use Python, because I'm using Windows or Linux. So if you type in Python, you get this. It's already installed in your system. If it's not, you can install it. Google Python, download the installer. In Windows, if you type Python into the command line, it's not installed, it pops up Windows Store, you just click it, installs. It's fantastic. So we are going to create, so I've already rehearsed this, but we'll pretend it's organic. I'm going to create a file, and it has to be a .py file, Python file. So I'm going to call it first.py. Then I'm going to open this up in a text editor. You can use Notepad. You can use the Python IDE like this. I'm going to use Visual Studio just because I already have. I'm just used to it. But you just open the file in a text editor. Right. First thing we're going to do, we're going to output some code. So we're going to use the first concept. So we're going to use a function. And a function is just like a command that does something. In this case, it's called print, and it prints output to the console. So, hello. Don't worry about the syntax right now. Just know that if you're in Python and you want to output something to the terminal, you type print, open parentheses, and within quotes, the text you want to display. And we're going to run Python first. So I've just tried to run an empty file. You need to save it. Hello. And you can change this. You could be like, hello, Fred. Hello, Fred. Now let's say you have so what we've done at the top here is we've declared a variable, and a variable is a place to store data. So within name we've stored Fred. So instead of writing here, we can write hello plus name. We want to get exactly the same output. The purpose of this will become apparent. Okay. So what we want to do is that right now we have a hard-coded name. Every time we run this program, it's going to greet Fred. But maybe I'm not Fred. Maybe I'm me. So we're going to use a input function. And as I've typed it, it's popped up with a little prompt of what it does. And within the parenthesis, we are going to define a prompt. The prompt is just a message to the user, what you want them to input. So please enter your name. Please enter your name. There you go. Now it's greeting me. So at the minute we've defined a variable. We've given it a string. Now a string, just to explain this concept. So if we do string A, this is a string. Whereas if I was defining a number, I would have to store that in a... Notice how the number does not have speech marks, but the string does. This is because when we define a variable, the variable can only... in Python it does not matter. You can store whatever you want in any variable at any time. But a concept that is useful to know is that a variable is cast as a data type. So whereas string contains a string of letters, where the name comes from, string of characters, i.e. words or text, but a number variable contains a number. So if you were to say this, that would mean it's still a number as far as a human being reading it is concerned, but the interpreter or the compiler or whatever you're running the code through will see that number as text. So a good example is, so first of all, let's comment out this code we don't want. And commenting out just basically means we put a little pound, little hash sign, sorry. We're just saying don't run this, just ignore it for now. So we're going to print number. And we're going to create a number. And I'm going to explain this concept very briefly. So let's do another. So we've got number A, 42, number B, 3. So at the minute, we're just outputting number A. But what would you expect there? You expect 45, because you're adding one number to another. Makes sense. Now let's say we define this variable or cast it as the wrong data type. So as previously explained, it's not going to let me do it. It's saying you can't add a number to a string because it knows what we're trying to do is, it doesn't make any sense. But if we define them both as a string, what's going to happen? Is it going to be 45? No. It's going to be 423, because when we join strings, it's not an it's not like a mathematical solution. We're not adding two integers, we're just joining two strings, which is called concatenation in this realm of development, or maybe that's the true name for it, I'm not sure. So variables, data types. So we have defined, let's go back to what we were doing. We went on a bit of a tangent there, but it was a good tangent. I think it was an important tangent. So we now know about defining variables, input, output, and the last thing we'll cover to keep it as like a 4, nice square, is if conditionals. And an if a condition is just if this is going to happen, do this. So for example, if. So who's logging in here? So if name is equal to, let's say it's my name. Okay, we'll print, I don't know, a smiley face, let's say. And let's say if the name is equal to Bob, let's do a frowny face. So obviously if it's not Clint or Bob, we'll not get any of these. So we're going to run it. What's her name? Clint. Happy face. Bob. Frowny face. Rick. No faces. So what's happening here? Well, we're comparing this variable, to another. It's actually another variable, but we've just, we've not defined this variable. We've just passed it right here. So if name is equal to this string here, print is equal to Bob. Now what we could do, so these two equal signs in the middle, is here between the variable and input we have one equal sign. So one equal sign means set this to this, set name to the result of input. But two equal signs means if is a comparison operator if name is equal to, and we also have Butterfingers is not equal to. So maybe he smiles when it's not me. See? And that is how you can define logic around different conditions you might detect. So you can really use your imagination here. Imagine, instead of comparing a name I've just inputted, it could be value in a spreadsheet. Maybe you want to set every value of something. Maybe it's a sales report and you want to set every value above 10. You want to colour that box in red. You might have to sit there. Maybe you can do it with macros or formula. Maybe that's a bad example, but okay, not a spreadsheet, but a table on a website. There you go. So you can imagine how those conditions are like the backbone of programming. And I'll just leave it there. Just leave it there. That's not going to be a full crash course on Python. And just to recap from the top, so the fundamentals you can apply, and it's a good thing to think about. Are you getting involved in supporting businesses with their problems? Hobbyist. I mean, if you're a hobbyist, you're any of these really. Are you going a security path, or a lot of programmers want to be game developers, so that's it's a valid path, but it's just something to think about. And then it determines what kind of tools and what kind of languages you're going to invest your time in, especially initially. But at this very crawling stage, all of the fundamentals are applicable to everywhere. It doesn't matter. And you've learned about variables, you've learned about input prompts, you've learned about outputting, you've concatenated two strings together, you know about casting variables as different data types, and why that's important and what happens if you try to do, for example, you try to do a mathematical operation on two variables which are not integers.